Welcome to the Architect's Guide to Modern Token Security. As we lay the groundwork for our enterprise security architecture for 2025, choosing the right token standard is a foundational decision. Today, we're going to walk through a comparative blueprint of two major players, JWT and PASETO. While JWT is the current industry standard, PASETO offers a modern alternative designed to eliminate common security pitfalls. We'll break down their specifications and trade-offs to ensure we're building on the most secure and scalable foundation possible. Let's dive into our first specification overview.
To set the stage, we'll start with the industry standard, the JSON Web Token, or JWT. For over a decade, JWTs have been the backbone of identity federation, powering protocols like OpenID Connect and OAuth 2.0. Its design is elegantly simple and stateless, consisting of three core components: the header, the payload, and the signature. This well-understood structure is precisely why it remains the default choice for modern web services.
When we look at the structural design of JSON Web Tokens, we see a core philosophy called algorithm agility. This means the token itself tells the server which cryptographic method to use for verification. While this sounds flexible, it is a massive design flaw, often called a footgun. As you can see highlighted in the header, the alg parameter is controlled by the user. The critical danger here is that the server is forced to trust this unverified data to decide how to perform its security-critical verification. By allowing an attacker to choose the algorithm before the signature is even checked, we open the door to numerous high-severity vulnerabilities. Moving on to one of the most well-known vulnerabilities in JWT security, the alg-a-none exploit. As you can see on the left, a standard secure token uses a defined algorithm, like RS-256, to ensure the signature matches the payload. The exploit occurs when an attacker modifies the header to specify the algorithm as none. If the backend library is improperly configured, it will take this instruction literally and skip the signature verification process entirely. By removing the requirement for a valid signature, the attacker can manipulate the payload and gain unauthorized access. This highlights why proper library configuration is just as critical as the protocol itself. Now, let's look at a newer specification, PASETO, which stands for Platform Agnostic Security Tokens. PASETO was designed as a direct response to the security vulnerabilities often found in JWTs. The core of its secure by design philosophy is the move from algorithm agility to versioned protocols. In older standards, the token itself could choose which algorithm the server should use, which often led to critical exploits. PASETO eliminates that risk. As you can see in the diagram, every token begins with a version. In this example, version 4. That version dictates the exact secure cryptographic suite to be used. Because the algorithm is fixed by the version, there's no ambiguity and no room for a developer to accidentally choose an insecure configuration. It's built to be secure by default. To truly secure a system, we should aim to engineer out vulnerabilities at the design level rather than just patching them later. A prime example of this is how PASETO addresses the algorithm confusion attacks that frequently plague JWT implementations. In a standard JWT flow, shown on the left, the server reads the alg header provided by the token itself to decide which verifier to use. This is a critical flaw because it essentially lets the attacker dictate the security mechanism. PASETO eliminates this vulnerability through strict versioning. As you can see in the secure flow on the right, the version string, such as v4.public, mandates exactly which algorithm must be used, like ed25519. The server no longer asks the token how it should be verified. Instead, the version provides an undeniable, tamper-proof instruction. By making the algorithm choice a requirement of the protocol version rather than a user-defined header, we effectively make algorithm confusion attacks impossible. Now, let's compare how these two standards handle their cryptographic primitives. JWT, which includes both JWS and JWE, is famously unopinionated. It supports a massive list of algorithms, leaving the selection entirely up to the developer. While this offers flexibility, it creates significant risk. Legacy options like RSA PKCS1 v1.5 remain available, despite being vulnerable to well-known Bleikenbacher attacks. In the JWT model, security depends entirely on the developer's expertise to avoid these pitfalls. PASETO takes a different approach by enforcing specific primitives through versioning. Instead of picking individual algorithms, developers choose a curated version. Version 4 is the current recommendation, utilizing modern, secure primitives like ED25519 and XChaCha20. For environments requiring strict NIST compliance, version 3 offers a specifically vetted enterprise suite. Ultimately, by making these choices part of the standard rather than leaving them to the developer, PASETO significantly reduces the risk of implementation errors. When designing modern enterprise systems, we have to think like architects. Just as an architect specifies different materials for a structural foundation versus interior finishes, we must apply the correct security tokens to the appropriate domains. A one-size-fits-all token approach is no longer sufficient for a secure infrastructure. Looking at the diagram, we start on the left with the public internet. This is the untrusted zone where our users interact with us via browsers and mobile devices. Those requests first hit the perimeter, which is managed by our API gateway and identity provider. This zone acts as a critical transition point, validating external credentials and exchanging them for tokens suited for our internal environment. Finally, we move into the internal core. This is our secure microservices mesh, or VPC. Within this zone, we use high-context internal tokens, which should never leave this domain, to facilitate secure, authenticated communication between individual services. By implementing this kind of architectural zoning, we create a layered defense, ensuring that sensitive identity data remains protected within the core while providing a seamless, secure entry point for our users. Let's start with Zone 1, the perimeter. This is where your system meets the public internet, and at this stage, interoperability is the top priority. When dealing with single sign-on or integrating with third-party APIs, JWTs are non-negotiable. The entire identity industry, including major providers like Auth0, Okta, Azure AD, and AWS Cognito, is built on the OIDC and OAuth 2.0 standards. Because these standards mandate the use of JWTs, they serve as the essential standardized handshake for any secure communication crossing the perimeter into your API gateway. Essentially, at this first layer, we use JWTs because the rest of the world requires them for seamless integration. Now let's move into Zone 2, the core. This is the area where security is absolutely paramount. In this zone, we are focused on internal east-west traffic, the communication happening between our microservices. Because these interactions occur entirely within our own infrastructure, we control both the issuer and the verifier. This gives us the opportunity to enforce a much higher security standard than we might at the network perimeter. For this environment, we recommend PASETO to support a true zero-trust architecture. Specifically, PASETO's v4.local mode utilizes symmetric encryption, meaning the token's payload is completely unreadable to anyone without the secret key. By ensuring the payload is encrypted by default, sensitive claims are shielded from view, preventing data from being exposed in system logs or intercepted during transport. This ensures that even within our internal mesh, our most sensitive data remains secure. For sectors requiring strict regulatory adherence, such as finance or government, PASETO offers a dedicated path to compliance. Version 3 was specifically designed to provide a secure-by-design solution using a full suite of NIST-approved algorithms. By mandating ECDSA P384 and AES 256 CTR, it satisfies typical compliance controls and FIPS 140 requirements right out of the box. This allows teams to meet rigorous standards without the risk and complexity of manually configuring JWE or JWS. If your environment demands NIST-grade cryptography, PASETO v3 is the recommended choice. When choosing between JWT and PASETO, we have to look beyond just the security architecture and consider the operational trade-offs. While PASETO offers superior security design, JWT currently benefits from a much more mature ecosystem. From a library perspective, JWT is universal. You'll find mature, battle-tested libraries for every language. PASETO support is growing rapidly in Go, Node, and Python, but it's still maturing in the Java and C# ecosystems. This maturity extends to cloud integration. JWT is a plug-and-play solution with native built-in authorizers for platforms like AWS API Gateway and Google Apigee.
PASETO, on the other hand, typically requires custom implementation, such as Lambda authorizers or custom middleware. We also see minor differences in day-to-day operations. JWTs are slightly smaller because they carry less metadata, and they are easier to debug since you can just base64 decode the payload. PASETO tokens are slightly larger, and because local tokens are encrypted, they are naturally harder to inspect during troubleshooting. Ultimately, while PASETO is the more secure choice, the maturity of JWT's ecosystem is a significant factor that must be weighed during your implementation planning.
Now, let's look at the master blueprint for enterprise token security. The goal here isn't to replace one standard with another, but to integrate them strategically. By zoning our architecture, we can leverage the strengths of different token types while mitigating their specific weaknesses. First, at the perimeter, we use JWT. Since JWT is the industry standard required for OIDC and OAuth 2.0 specifications, it is essential for interoperability with public APIs and external clients. Second, as data flows into the internal core, we recommend adopting PASETO. PASETO is built for zero-trust architectures. It offers a more secure, hardened approach for internal service-to-service communication, specifically using the v4.local implementation to avoid common JWT vulnerabilities. Finally, the foundation of this strategy is unified key management. By centralizing key storage and rotation within a KMS, we ensure consistent security policies and operational efficiency for both token types across the entire infrastructure. This tiered approach gives us the best of both worlds: standard-compliant external access and high-security internal operations. Building securely is about more than just checking a box. It's about intentionality. The decisions we make, such as choosing between different token formats, aren't just technicalities. They represent a deliberate effort to match the right tool to the specific job at hand. Moving beyond a one-size-fits-all approach is the true hallmark of a mature, resilient system. It requires us to look at the unique needs of our environment rather than relying on defaults. As you evaluate your own projects, I want you to consider this fundamental question: is your internal architecture truly secured by design? To wrap things up, we've provided some additional resources for your reference. For the full technical specifications, you can refer to RFC 7519 for JWT and paseto.io for PASETO. On the security side, we want to specifically highlight the JWT algorithm confusion vulnerability as a critical area to watch for during implementation. To help you build securely, we've listed our vetted and recommended libraries for both Go and Python. Using these will help ensure you're starting from a solid foundation. If you have any further questions or would like to schedule an architectural review for your specific project, please reach out to the Security Architecture team at the email address shown here. Thank you.